In this video, we're going to learn about a technique called source transformation. Now, you may remember in earlier chapters when we had two resistors, we could combine them together into a single resistor in the series case by just adding up R1 plus R2. Now, what that meant was we were finding a mathematically equivalent circuit that anything outside of it would not be able to tell the difference. So if you have some big complicated circuit, and in one part of it you have these two resistors in series, and you were to manually pull those two things out and put a new single resistor with the value R1 plus R2, everything else would work the exact same. You would never know that there was a change. Again, it's not an equal circuit because inside the circuit, if you were to actually look at that part where the resistors were, you could tell the difference by seeing two resistors or one resistor. But everything else in the circuit would still work the exact same. So again, what mathematical equivalence is yes, the circuit may actually physically be different now, but as far as anyone else can tell in the circuit, it's the exact same thing it had before. And this is very important because in this source transformation here, we're doing something that's a pretty drastic change. So what we're saying is that if you have a voltage source, a battery, in series with a resistor, that is mathematically equivalent to a current source in parallel with a resistor. And so again, a current source and a voltage source, they're two different things. A voltage source tries to keep a constant potential difference between 2 points. The other one tries to keep a constant current running through it. Very different ideas of what's going on there, but mathematically, to anything else in the circuit, you would not be able to tell a difference whether you had a voltage source in series with a resistor or a current source in parallel with a resistor. And there are going to be times when using this source transformation can really make a circuit a lot easier to analyze. Now, if you want to actually do the conversion, you need to know what the relationship is between the voltage, resistance, and current here. First, note that the resistance in series is going to be the same value as the resistance in parallel. That's an important point. The second thing is if we want to find the relation between the voltage and the current, it's actually a really nice, easy formula. The voltage of the source for a voltage source is going to be equal to the value of the current source times the resistance. So it's actually just V equals IR, which you're used to in many other cases. I do want to point out that this is not Ohm's law. Even though it looks like Ohm's law, this is not Ohm's law. And there's a couple of things that I need to say why that's the case. First off, Ohm's law is dealing with the current through a resistor and the voltage across the resistor. Well, over here in this right circuit, this current is not all going to go down to that resistor under normal circumstances. Normally, you're going to have something going on over here on the side. And so the current's going to get split up in some way, and the current through the resistor is not going to be IS. Similarly, you would normally have something going on over here, and the voltage across the resistor in that first picture is not going to be the same as the VS, the voltage across the source. So we're not talking about current through resistor, we're not talking about the voltage across the resistor, so that's why it's not Ohm's law. There's also another problem with Ohm's law here. Because in Ohm's law, under passive sign convention, you're supposed to have the current going into the plus side of the voltage. But if you look at this, again, it's not quite right because they're not in the same picture, but it looks like you're talking about current coming up here, which if you imagine it in the other picture, it would be leaving the positive side. So this can really mess up your intuition on passive sign convention, and I hope you're able to not have that problem. But just remember, if you're ever going to switch a voltage source to a current source, make sure that the current source arrow is pointing the same direction that the plus side was pointing towards, and vice versa if you're switching a current source back to a voltage source. So it's still V equals IR, but you should remember it's not actually Ohm's law.